look at a few examples of factoring with greatest common factor, and these look a little different than your standard ones, but the principles still apply. And something that's very critical to understand here is that if I have a to the m times a to the n, that's the same as a to the m plus n, and we'll rely on that fact heavily in these examples. Okay, but other than that, the principles still remain the same. So generally when you're factoring with greatest common factor, you take out, so for example, if I said something like this, if I have x squared plus 3x, I know I can take an x out of everything because an x is common to all my terms, and the smallest power of x that's common to all of my terms is x to the first power. Because so this idea of the smallest power is what we really need to figure out here. So in this first example, we have 3z plus 2 to the 5/3 power minus 3z plus 2 to the 2/3 power. So we can see that I have a common factor out of both of these terms. That's a 3z plus 2, but to what power? Okay, so the smallest of these is the 2/3 power. So I can take out a 2/3 power. And when I do that, I have 3z plus 2 to some power. Let's figure out what that power is in a second. I'll come back to that. And the second one, I took out 3z plus 2 to the 2/3, so I took out everything. So I'm just left with a 1 here. Okay, now going back to the first term, I had a 5/3, and now I took out a 2/3. So if you think, the 5/3 was on this side of my equation down here, and I took out a 2/3, so the m might be a 2/3. So 2/3 plus what gives me 5/3, and you can see then that would be 3/3, which actually works out very nicely for us because this ends up being 3z plus 2 to the 2/3 power times, well, the 3/3 power is just the first power, so I end up with 3z plus 2 minus 1. So finally, that's 3z plus 2 to the 2/3 power times 3z plus, well, 2 minus 1 just gives me 1. And there it is. There it is factored. Okay, we'll apply this same technique to question B that says 5x to the negative 4th power minus 4x to the negative 5th power y. And again, I want to, so I can see I have some x's common in both of these terms. I want to take out the least exponent of x. So in the negative sense, the least exponent here would be x to the negative 5th. Okay, so if I take out an x to the negative 5th out of both terms, my first one you have 5x to some power. Let me figure that out in a second. We'll come back to that one again. In my second term, I took out the x to the negative 5th, so I'm left with just a 4y. Okay, so what power should this first term have? Again, it's the same idea. On this side of my equation, I had m plus n is negative 4. And here my m was a negative 5. So negative 5 plus what gives me a negative 4? I can see this is actually supposed to be x to the first power. So I end up with x to the negative 5th, 5x minus 4y. If you have any questions, please let me know. I'd be glad to help. And thanks for listening.